Welcome back to the channel. So today we are going to study why oxygen dissociation curve is sigmoid. First of all, oxygen dissociation curve is sigmoid because of positive cooperative binding of oxygen to hemoglobin. If suppose it is not cooperative binding, if it is directly proportional, if we say if this relationship is directly proportional, then we would have got this curve, straight line curve. Then we would have achieved this straight line curve. Clear? This one. But we know oxygen dissociation curve is not straight line, it is sigmoid. Clear? It is sigmoid. This one. Please focus this diagram, green color I am using it. It is sigmoid. Because relationship between saturation and oxygen concentration is not directly proportional. It is not directly proportional. It is actual cooperative binding because of which it can take the oxygen very easily and it can lose the oxygen also very easily. So actual relationship between saturation and oxygen concentration is not directly proportional, with most of the increase over a narrow range of oxygen concentration, and we get a sigmoid curve. Before understanding in detail, first try to understand few basic things. What is the structure of hemoglobin? It has got 4 polypeptide chain with 2 alpha and 2 beta, and each chain contain one heme group. You can see this is heme group. I am highlighting with the yellow color. And each heme group is having one iron. Okay, each heme group is having one iron. You can see I am just putting this with blue color. It is an iron. And each iron can carry one oxygen molecule. The one hemoglobin can carry maximum of 4 oxygen molecule. Now what is cooperative binding? For this you can understand one analogy. Suppose you go to the theater, you will generally see the seats are folded. So one person is putting an effort to make it straight and he's sitting it, and because of his pressure or whatever, you can see the other three are now becoming, next chair is easily, second person can sit, then third person can sit, and obviously all four can easily sit. So this is the analogy to understand how the cooperative binding is working. If you see here, your first oxygen binds with difficulty with the hemoglobin, but second bind easily, third even more easily, and fourth obviously very easily. The cooperative binding means binding of one oxygen molecule increases the affinity of hemoglobin for the next oxygen molecule. We say it is known as cooperative binding. Now the question comes, why does the cooperative binding happen? First of all, we should know hemoglobin exists in two conformation. One is tense state, which is having low affinity for oxygen, and second is R state, relaxed state, which has got very high affinity for oxygen. So the moment the first oxygen bind, it pulls the iron into a plane of the heme group, bringing the conformational change in the protein structure so that other oxygen can easily bind. So this is the reason why cooperative binding works. Now question come in the mind, why the curve is sigmoid. Now see, when the partial pressure of oxygen is low, obviously less oxygen is available for the hemoglobin. Okay, and it is right now in the T state. So oxygen binding is very slowly after one or two oxygen molecule binding, it changes to the R state. Oxygen binding become very easy, and now slowly it comes to the middle portion. And when all four binding sites are occupied, very few sites will be free. So it has reached to the plateau stage. So this is your, when your partial pressure is low, A point, this is for B, and this is for C. Clear? So it means oxygen dissociation curve is S-shaped because initial binding is difficult, but later on binding affinity increases because of cooperative binding. Clear? Now you know very well, we say 100 ml of blood will carry how much ml of oxygen? It will carry 20 ml of oxygen. Clear? But it will deliver how much ml of oxygen to the tissues? It will deliver only 5 ml. Remember na, it will deliver only 5 ml. The 5 ml of 20. It is 25% it is delivering. In the rest condition, only 25% is delivered. It means in the rest condition, please focus carefully, in the rest condition, understand this diagram, in the rest condition, still hemoglobin is 75% saturated. In the rest condition, still hemoglobin is 75% saturated. Okay, in the systemic vein, in the vein. And this is C point is actually for the oxygenated blood in systemic arteries. So I hope so this video might be helpful for you to understand why oxygen dissociation curve is sigmoid.